Hi, I'm John Standish. I'm a solutions architect with AWS, and I was a developer before I came here. So working with packages was something I was very familiar with, especially working with package managers. Um, Companies often use package managers to control and restrict possibly the security of the packages from third-party package managers. They may have local shared packages such as auth, encryption, and want to standardize on versions. So let's walk through a customer, Stackery in this case, and the benefits they got out of using CodeArtifact. Stackery had issues with a open source package they were using. It had a connection pooling issue in it when they were trying to connect to a database. This caused the application to have those intermittent connections and connection failures. So what they ended up doing is they took a version of the package, modified it, and checked it into CodeArtifact. This way they didn't have to wait for the upstream package author to go ahead and fix that. So what is CodeArtifact? Well, CodeArtifact is a managed artifact repository. Let's walk through some of the core concepts of CodeArtifact. So with CodeArtifact, you have a domain, and a domain is an aggregation of multiple repositories. And repositories they contain a set of packages, each which map to a set of assets. And those packages are a bundle of software together with metadata required to resolve dependencies and install software. And inside those, you have assets. And assets are individual files stored in CodeArtifact associated with a package version, such as an npm tgz file, maven pom, jar files, NuGet NuSpec files, and the like. CodeArtifact supports multiple different package managers. With Java, you have Maven and Gradle, so any Java-based language, such as Kotlin, Scala, or Clojure, is also supported. JavaScript, you have NPM and Yarn you can use. With Python, you have pip and Twine. You also have NuGet support for .NET. And there's many more languages to come, and I encourage you to reach out to your team or to the community about which languages you want to see supported. Now let's walk through an end-to-end demo of CodeArtifact in use. We're going to provision our resources, so our domain and a repository. We're then going to take a project that is currently not having a package that we're going to build, push into CodeArtifact, consume that package, and fix that project. So let's walk through that. CodeArtifact, you can find it in the AWS console by going to Services. It's down here in the Developer Tools under CodeArtifact. Or you can type it in here and select the service. So let's go there. We're going to select our service. And if you look in here, we don't have anything provisioned. We don't have any domains, nor do we have any repositories. So let's go ahead and provision those. We're going to go to CloudFormation. We're going ahead and click Create Stack. And we're going to upload our CloudFormation template, which we'll go into in a little bit in the details of that CloudFormation template. Let's give it a name, reinvent in this case, for the stack, and hit Next. We're going to go down, click Next, and we're going to provision that stack. And we're going to watch that stack. It should be done any moment. And now that our repositories and domains are created, let's go into CodeArtifact inside the console and see what's been provisioned. So if you look in here, we have two repositories that have been created, My Team repository and an external repository. So if we click on My Team repository and we go to the details, you're going to see there's an upstream connection to my external repository. If we click on that, there's a connection to an external repository, a public one. This is NuGet.org. And we'll go into detail later on about what external and upstream connections are. Let's go over here in the Visual Studio, and we're going to look at a package or a project here that currently does not have reference to CodeArtifact sample. That package does not exist. So if we look up here, you can see in our project, in our C# file, it will not compile. We do not have a reference to the package. We do not have the classes that are being outputted for logging. As you can see here, it doesn't exist. So let's go over to our shared project, which has a reference to Log4net. This is a wraparound Log4net. And let's go ahead and install Log4net. As you can see, it hasn't been brought in. So we'll go over to the project and we'll hit Manage NuGet Packages. We'll go ahead, type in Log4net, and we'll see it. One thing I want to point out is this is using CodeArtifact as a package source. So if you look here, we're not using the public reference to it. We're using only CodeArtifact to pull the packages through. So I'll go ahead and hit cancel, and I'll go ahead and install. So we'll install this package from Log4net, and it installs, and you'll see all these errors go away. Now let's go ahead and compile this, make sure everything's working. And we're good to go. So now we want to be able to push this package up. We're actually going to publish this package. So we're going to use .NET Pack and .NET NuGet Push, this native commands in .NET. But first what we need to do is we need to log in to CodeArtifact and get an authentication token to push. So I'm going to go up a directory into the support directory and run login ps1. That's just a wrapper around the AWS CLI to get an authentication token. As you can see here, it successfully grabbed an authentication token. That's good for 12 hours. I'm going to go back, and then I'm going to publish this package up. And as you can see, it successfully pushed the package using .NET Pack and NuGet Push, and it's pushed up to our team repository. So now let's go back to our project, our main project, and pull down that package now that's been pushed to CodeArtifact. Go back to Manage NuGet Packages. Our CodeArtifact, our source is set to CodeArtifact. And I'm going to type in shared, since that's the name of the package that we pushed up. And there it appears, and we're going to hit install. So now that that's been installed, let's go back. You'll see the errors go away. And let's go ahead and run this. And there you go. As you can see, we're using the Log4net wrapper, and everything is working. Let's go ahead and close this. Let's go back to CodeArtifact. Let's show what lives inside the repositories after we pushed up. So I go to my external repository, there's nothing there right now. If I go to my team repository, what you'll see is you'll see the shared package that we pushed. And I'm going to navigate into that. You'll see the version we have here. You'll see the assets that are in here. It's a NuGet package that was actually pushed up, and the dependency on Log4net. And everything resides within there. So now that you have seen us provision repositories and domains, how do you manage these? How can you control the sprawl now that you can have n number of repositories? You have multiple repositories. And often you had 1 or 2 or 3 repositories, and as more packages became available and more repositories were needed for segmentation, it became increasingly difficult to organize, trace, discover, and govern the sprawl. So how would you do that? Well, what we provisioned in our demo was a shared repository. That shared repository had a connection, an external connection, to NuGet.org. Now, an external connection allows the packages within the public repository, here in NuGet or NPM, whatever you choose, to be referenced and pulled through to the shared repository. Also, when you pull through a package, it will keep a copy in CodeArtifact for that version, so that if something should happen to the upstream repository that you see here, you have a copy and you can go along your way. We also provisioned a team repository, but you could also provision different other kinds of repositories, such as a sandbox or even a functional repository. Now, a functional repository is one that's split by a domain in domain-driven design, or a service, or another functional boundary. Shared could contain packages such as authentication, logging, or any other commonly used packages within your organization. Now, say you wanted to pull packages from the shared repository. You wanted to have visibility into those from your team repository. Well, that's where you would establish an upstream connection. An upstream connection enables the package manager client to access packages that are contained in more than one repository via a single repository endpoint. Now, say you wanted to iterate on those packages, and you would do that with your sandbox repository. Well, by having that, you can create an upstream connection from your team repository, connect it to your sandbox repository, and now you have reference to the packages that are in team and shared. Likewise, when you push up into the team repository, when you promote, all the packages and references are maintained and not broken. And we provisioned this using CloudFormation. And let's walk through what the CloudFormation was that we used to provision this. So we created a domain, and we gave it a name. This is example domain. And we have my shared repository. In my shared repository, it had an external connection. In this case, we changed it now to npm.js. We could use NuGet.org or Maven Central. And then we also provisioned a team repository that had an upstream connection to the shared repository. And this is how that connection is made, using that git attribute. Now, if you were to use a build system to push up, which most of us do, how would we do this? Well, you can use an existing CI system. You could use also code build, or any other tool you use to build your packages. So what we do is we use the AWS CLI, we use CodeArtifact login, and you specify the tool. In this case, it would be npm. We specify the domain, and here it's my org, and the account ID, that is the domain owner. This allows you to have cross-account usage for logging in. We then specify the repository that we want to log into. Now, what this is doing is it's going to give us an authentication token that we can then use in our native package managers, and our package manager clients. Next, run our npm command, in this case, npm run build. We'll set the version of the package, and we'll push it. Now that we've pushed the package up, say you wanted to promote from our sandbox to our team repository. Well, you can do that using the copy package version. The copy package version, you specify the domain and domain owner the same way you did with the login, but you specify the source and destination repositories. Here, we're going from my team repo to a shared repo. Specify the package, the format, and then the version. Now, what this will do is it will not copy a instance of the package. Instead, it will copy a reference to it. What this means is that the storage itself is deduplicated underneath. You don't double pay for having two references to a package. There's only one instance. And what this allows you to do is near instantly promote a package from one repository to another. Now that you've been able to build and promote and provision your packages with CodeArtifact, how would you consume this with your team? So as developers, we'd want to be able to pull those packages using our native tools. And there's a couple ways of doing it. One was through the AWS CLI that you saw there. Now, if you forgot what the command is to run it, you can go to the console and hit View Connection Properties. It will bring up this modal here, and you can select your package manager. Here we'll select npm, and then it will give you the snippet of the tool here for you. You'll take that, put that in your CLI, run it, and you're good to go. Then you can use any of your native tooling you have today. You can use npm or yarn we mentioned earlier for JavaScript, doing an npm install. With Python, you could use pip or twine. With Java, we talked about Maven and Gradle. You can use all of those. And with .NET, you can use .NET CLI or even NuGet. Now, underneath, what's happening with the npm one is it's modifying the npm.rc file. It's putting in the registry URL and the authentication token for you. In .NET, it's modifying the NuGet conf file. And in Python, it's modifying the PyConf file for you, and also works in a virtual environment. Now, a common restriction of existing artifact repositories was you had to abide by either an API or a plugin. And it was made it harder and harder to extend it. With CodeArtifact, you have access to extend this using CloudWatch events to fit your organization's needs. So let's watch some advanced use cases. Here's an example of a promotion pipeline with multiple stages in it, where you have a team repository, a staging repository, and a production repository. Now, the developer goes ahead, they check in their code, and here in code commit or any repository, that triggers a build and publishes into our sandbox repository. That sandbox repository fires an event that says a package has been created or updated. That will then trigger a flow. In this case, it's configuring or firing a step function flow. That step function flow goes through multiple steps. In the team repository stage, it could be doing some basic UI testing, maybe some compliance checks, maybe some security scans. If that's successful, it pushes into the team repository and then goes on to the next stage. And as it gets to production, it gets continuously more strict on the types it's testing. Another flavor of this could be if you had a quarantine repository that ran a workflow to check for licenses, do some code scanning, that would then eventually promote that into a shared repository. That's another flow you could use. Another extension you could possibly do is dependency-based notifications. Often when you're developing and you're using package managers, there's versions assigned to it, and there's new packages that are created. Well, how do you get a notification if the package you're using changes? Maybe a team has updated something, fixed a bug, added a new feature, and something of that nature. How would you get a notification? Well, in this case, we've done the same subscription with a CloudWatch event for the package, and then we have the repositories with the packages split into a Dynamo table. That has references to which versions and packages are used for a particular repository, or actually for a particular project. We then have a list of Slack channels with those repositories as references. We connect in those. Based on the version that changes, we fire into the channel a message to say, hey, this package has changed, and you now have complete visibility into that. So if you were trying to get around a bug or there's something happening, you have visibility. Okay, I don't need to continue on this. I'd have immediate visibility. So let's walk through real quick what we just covered and how using CodeArtifact is different than the self-managed ways that many may be doing today. With the self-managed, you're required to set up, operate, and manage the scaling aspects of it. With CodeArtifact, you only have to worry about the domain, the repositories, and security. So security being resource policies themselves. You also have limited durability and security because you had to control that yourself. You had to set up the storage arrays, you had to set up the encryption at rest, any of that, things of that nature. With CodeArtifact, you inherit the durability and security. The durability for the storage comes because CodeArtifact is backed by S3 with its 11 nines of durability. You can establish a zero trust policy using resource policies and IAM, and it's encrypted at rest by default, or you could bring in your own encryption keys using your own CMK. You also had upfront fees for your self-managed ones. You had to purchase an enterprise version, and that required a sizable investment. With CodeArtifact, you only pay for what you use. You pay by the request, and you pay by the storage. And remember, multiple package versions are deduplicated, so you only pay for that one instance of the package. And then there was limited extensibility. The extensibility only by the API or the plugin for the existing self-managed repositories. Now, you can extend using CloudWatch events to fit your company's needs. We also talked about native tool integration with NPM, with NuGet, with Python, and with Java. We talked about CloudFormation support and how you can quickly spin up domains and repositories, and how you could extend that using CloudWatch events. All the code that we used is available here in this GitHub link, and so you can get started today. I just want to say thank you, and I hope you have a wonderful reInvent. Please fill out the survey. Thank you.